Hi everyone, welcome back. In this video, I will discuss the solution to the problem subarrays with equal number of occurrences. In this problem, you will be given an array and two integers x and y. You need to find the number of subarrays in which the number of occurrences of x, that is frequency of x, is equal to the frequency of y. So for this example, this is the array which is given to us and the value of x as 1, the value of y is 2. So here how many subarrays are there which has same frequency of x and y. So this is the first subarray where we have a frequency of x as 1 and the frequency of y also 1. Then this is another subarray where the frequency of x and y both are 1. So the expected output in this case is 2. So let's see how we can solve this problem. So let's just assume this array where we have some element, then we have our first element x, and then we have our element y, then again x, then y, and then another occurrence of y maybe at here. So let's just quickly analyze the approach. So let's say we are currently at here. Let's say this is the current index I. So what are the informations that we need? And if we are traversing from left to right, that is from index 0 to index n-1, then we can easily store the frequency of x in the prefix from 0 to I and the frequency of y in the prefix from 0 to I. So let's say count of x, that will just simply store frequency of x in a subarray, or you can say prefix from 0 to current index I, and let's say the count of y is storing the frequency of element y in a subarray from 0 to I. Cool. So for the current value of I, the count x is equals to 2, that is frequency of x in the subarray from 0 to I is 2, and the count y is equals to 1. And what is their difference? So let's just find this difference. So difference, which is simply equals to count of x minus count of y. And here I am using count of x minus count of y, but you can also use count of y minus count of x, but make sure to use the same formula throughout the loop. And this will simply equals to 2 minus 1, which is equals to 1. So what does it mean? It simply means if from 0 to I the difference is 1, that is simply it's equals to 2 minus 1, which is equals to 1. So from the current index I just wanted to know how many subarrays are there, how many prefixes are there which has the difference as 1, because so that the area which is in between I and that subarray would have the frequency of x and y as same. So what I'm trying to say, so my answer is simply equals to number of indices which having value less than I, number of indices less than I, and having difference, let's say what we can say, having count x minus count y equals to this current difference, that is current count x minus count y. So at this point of time that the value of difference is equals to 1. So I wanted to know how many prefix, or you can say how many indices are in its left for which the difference is 1. So this is the only index for which the difference is 1. So, and of course I'm talking about the subarray from 0 to that index, basically the prefix part. So here what is the frequency of x? It is 1. And what is the frequency of y? It is 0. So 1 minus 0, which is equals to 1. So here the difference is 1. So and here also the difference is 1. At index I we have 1, and at this index also we have 1. So what is the frequency of x and y at here? So here the frequency of x and y gonna be the same. That's why we have this same difference. Here we have 1 and here also we have 1. So that's why the area which is in between these two indices are having frequency of x equals to frequency of y. That is a count of x is equals to count of y. And this is the complete approach. So we can use unordered map, and in case if you are using Java, so it is a hash map. Unordered map, you can also go with the map. So unordered map, and we can store every difference. So that is hash every difference. And before hashing this thing, I will just simply find the answer, that is tell me the number of prefix in its left which are having the same difference, because the area between those two indices will have a difference which will have the same frequency of x and y. So let me just show you the implementation. So here I have taken the size of this array, then my answer variable and count of x, that will simply store frequency of x in the prefix from 0 to I, then count of y will simply store the frequency of y in the prefix from 0 to I, and then we have this mod as a 10 power 9 plus 7, because answer can be very large. So that's why we must have to reduce this answer within some range. So that would be 10 power 9 plus 6, because a mod b is equals to a. The range of a mod b is from 0 to b minus 1. That's why up to 10 power 9 plus 6 only. So then here I am having my map for a hashing purpose, and then MP of 0, which is equals to 1. So what does it mean? So there might be the case when for a particular index I, this difference is equals to 0. So if this difference is equals to 0, then in the entire prefix we have same frequency of x and same frequency of y. So that's why I have added this base case. Otherwise you can also handle it separately. So if element is equals to x, then count x plus plus. If element is equals to y, then count y plus plus. Then what is the required value? That is the difference, count x minus count y. And then I will just simply increment my answer by that number of indices which has this required difference. Then I am taking answer with I'm taking mod with mod, and since we got the same difference, so that's why I have hashing this difference, that is incrementing its frequency in a map. And since we have to return integer answer, so that's why I have converted it into integer. The time complexity is linear because we are using unordered map which supports insertion deletion in just constant time, and since we are using a map, so that's why the space complexity is linear. So let's just try to submit this. So successfully submitted, and thank you so much guys for watching this video, and have a good day.